This mini byte is linked to atomic structure, part of the C4 OCR GATEWAY GCSE. Everything around us is made from atoms, and every element will have unique structures of their atoms with regards to the particles that are found inside. There are three key subatomic particles that are found inside atoms that you need to know about for GCSE and where they are found. To start with, let's talk about the key parts of an atom. Inside of an atom we have something called a nucleus. And there are actually two key particles that you need to know about that are found inside the nucleus. Around the outside in what are called shells is the third particle. They are different, and they are different in slightly different ways. They're different in terms of their mass and how their mass is compared, and they're different in terms of their charges. In the nucleus we have got two key particles. The first one, this pink one, are called neutrons. Again, we'll talk about neutrons in a couple of seconds. The blue particle that's got a plus sign, they are what are called protons. And the particles that are found in shells, or what we know as electron shells around the outside, and again there's another mini byte linking to electron shells, have that negative charge, and they are electrons. The subatomic particles found inside don't just differ in terms of where they're found, they also differ in terms of their mass and their charge. Protons and neutrons are given the value of 1 for their mass, as their masses are relatively similar. In comparison, electrons are about 1,870th the mass of a proton or the mass of a neutron. If we actually calculate that, the decimal will be 0.00005. Quite a difficult number to remember, but a good one, because it's a common question leaving that number out and getting you to write what that number should be. So masses of electrons in comparison are very, 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 very small compared to a proton, compared to a neutron. That's why the mass of the atom is pretty much found inside the central nucleus. Charges, however, depend on which particle you've got. Electrons, for example, have a -1 charge. Protons have a +1 charge, and we'll come to the relevance of that negative and those positive charges a little bit later. Neutrons, however, have a 0 charge. They're what are described as neutral. They're neither positive or negative. When it comes to calculating how many protons, electrons and neutrons there may be, we use the periodic table. Every box on the periodic table tells you actually a significant amount of information, and its position in the periodic table does as well. We're going to start by looking at what's inside the box rather than the position the box has. And in group 1, which is the first column on the periodic table, you'll see an element called sodium, a metal. Has two numbers written inside the box. Has a number 11, which is the smaller of the two. And this is what is called the atomic number. The atomic number is the number of protons that that particular element contains inside its nucleus. So in the case of sodium, sodium has got 11 protons. The number at the bottom is the mass number. The mass number is different. The mass number just tells us how many particles are found inside the nucleus. We know already that those particles are either protons or neutrons, but the mass number doesn't tell us about how many of each there may be there. However, the atomic number can help us with that. Another thing about atoms is the fact that they are in fact neutral. We already know in the case of sodium, sodium has got 11 protons, so technically has got 11 positive charges inside the nucleus. If an atom is neutral, there must be 11 negatives that have the ability to cancel out those positive protons. Every positive can be cancelled out by a negative. What that means is if we have 11 positive protons, that means to cancel out those charges we would need 11 negative electrons. So inside an atom, a key rule you need to understand is that the protons equal the number of electrons. So your atomic number in an atom doesn't just tell you how many protons there are, it can also tell you how many electrons there are. Okay, so the easy bit with calculating particles is really using this number, the atomic number. So straight away we can see that we have got 11 protons, and as we just talked about a second ago, because of the fact that the atoms are neutral, the number of protons will equal the number of electrons. So that must mean there are 11 electrons. Now that's kind of the easy part. Calculating the number of neutrons is a little bit more complicated. However, the mass number can be used to calculate the number of neutrons. So neutrons and calculating neutrons are a little bit more challenging. We know that our atomic number tells us how many protons there are, and because we're talking about a neutral atom where the number of positives and negatives will cancel each other out, it also tells us how many negative electrons we have as well. In the case of the mass number is a combination. How many protons and neutrons are there together inside the nucleus? The good thing is we actually know part of that story already. We know there are actually 11 protons. So that means out of 23 particles here, 11 of them are in fact protons. So 23 subtracting that 11 leaves us with 12 neutrons. An easier way that you might find a little bit more helpful in the exam is to take the mass number and to minus the atomic number. Have a go at this example. Atomic number tells us the number of protons. In a neutral atom, the number of protons is the same as number of electrons. The mass number tells us how many protons and neutrons there are together in total. Out of that 24, we know 12 of them are protons. This means 12 must be neutrons. You may in the exam be given this word, isotopes. May come across in a variety of different questions. Isotopes are the same element. We talk about isotopes of carbon, isotopes of chlorine. They have similarities, but they also have one key difference. When you look at isotopes, one thing you would notice is that they have exactly the same atomic number. However, they actually have different mass numbers. I will come to that relevance in a couple of seconds. So what does that actually mean? What that means is the number of protons is actually the same because the atomic number doesn't change. However, in the case of isotopes of a particular element, the neutrons are actually different. And this is quite important. That's why the mass number is affected only. Remember, the mass number is how many protons and neutrons are together inside the nucleus. So let's have a look at an example. Chlorine actually has two isotopes. It has an isotope called chlorine 35 and has an isotope called chlorine 37. That can sometimes be written as the full name with the number following it. In the case of chlorine 35 and chlorine 37, the numbers that we talk about in the name is basically their mass number. You'll notice that the atomic number, as we said in our definition, is exactly the same. This means that in the case of chlorine 35 and chlorine 37, both will have 17 protons. Both exist as atoms, neutral atoms, which means if both of them have 17 protons, they are going to be balanced by 17 electrons. This is where we then start to see the difference. Remember, a definition of an isotope is that they have the same atomic number but different mass numbers. If they have the same atomic number and the number of protons are the same, the only particle that can be changing must be the number of neutrons. So remember how we calculate. We take the mass number, 35, and we subtract the atomic number of 17. So in the case of chlorine 35, there are 18 neutrons. In the case of chlorine 37, however, because we have a mass number of 37, so 37 particles inside the nucleus of a chlorine atom, and 17 of those are protons, we actually have 20 neutrons. You also need to have an understanding about how to calculate these subatomic particles in ions. There is going to be another mini bite that focuses on ions and ionic bonding, okay, for those that need to watch it. But just at this moment in time, to give you a bit of an idea of what an ion actually is, an ion is basically a charged atom. An atom that has a positive or negative charge, whereas normally it would be neutral because of the fact that the number of protons and the number of electrons would be the same. If that comes out of balance, so if there are more or less electrons than there should be, you can then create a positive ion or a negative ion. In the case of a positive ion, that would be formed if electrons had been lost. And how positive the ion is really determined on how many electrons have been actually lost. In the case of a negative ion, we're talking about gain. So gain of electrons, and again, however many electrons have been gained will determine how negative the ion is. It could just be a -1, but it could also be a -2, just like you could have a +1 or a +2 positive ion. To really kind of understand how ions are affected in terms of their subatomic particles, it gives you the ability to really appreciate what's happening and to hopefully help you if you actually understand why substances might become positive or negative depending on what's happening. And it's all to do with what's inside the atom. We know that normally in a neutral atom the protons will equal the number of electrons. So if we just focused on lithium, okay, and lithium has got an atomic number of 3, so normally it would have 3 protons, 1, 2 and 3, and normally in an atom, to balance that charge, it would have 3 negative electrons. In the case of sodium, and in the case of lithium and potassium and anything actually found inside group 1 on the periodic table, the first column, when they react, they tend to lose one electron from their outer shell. So one of them just doesn't exist anymore. If you then go back and actually have a look at what's then happened, when it was an atom, the number of protons 3 and the number of electrons, which was 3, actually balanced. But now we're in a position where the protons and electrons do not equal each other anymore. If a proton cancels out a negative electron, we would have a situation where this proton will be cancelled out by this negative electron, this proton by this negative electron, but actually this proton has nothing to cancel its charge out at all. So when lithium forms an ion, and when it loses one electron from its 3, it forms a +1 charge because of that extra proton that is not then cancelled out. So let's have a look at another example. This is magnesium. If we look at magnesium, we can see that it has an atomic number of 12. So straight away we can say it has 12 protons. As we saw earlier, it has a mass number of 24. So if we look at the difference between those two values to work out the number of neutrons, it has 12 neutrons. In terms of working out the electrons, we have to look at two things. We have to look at how many electrons we would have started with just purely as an atom. So in an atom, if there are 12 protons, there must be 12 electrons. However, what we have to consider is the charge on the ion. Because magnesium forms a +2, that tells me that 2 electrons have been lost. If we started with 12 electrons here and 2 electrons have been lost, an Mg2+ ion only has 10 electrons left. Try this example. Start by working out how many protons, electrons and neutrons would just the atom have. Atomic number of 11 gives us 11 protons, and in an atom, a neutral atom, would also have 11 electrons. Looking at the mass number and the difference between those two, that gives me 12 neutrons. However, there's a +1 charge on a sodium ion. That tells me that 1 electron has been lost. We started with 11 electrons, but if we lose 1 electron, we will only have 10 left. So in summary, when you're working out protons, electrons and neutrons using your atomic number and your mass number and potentially the charge of the ion, okay, there is a difference if you're looking at atoms, isotopes and ions. In the case of atoms, you will need to be able to use those two values in order to be able to calculate the protons using the atomic number, the electrons using the atomic number and the neutrons using the mass number, minusing the atomic number. In the case of isotopes, it's important to remember, because they have the same atomic number and they have different mass numbers, in different isotopes, the neutrons will be different. In the case of an iron, ions will be different and the electrons will differ between them.